So hey guys, welcome back to the channel, and as of this video, this is a 9th standard video and this class 9 chapter 2 polynomials. So if you have followed along with our session of classes of 9th standard, then as of the previous video we took the polynomials chapter, and in that polynomial chapter we saw what are zeros and many more concepts within that chapter. So as of this chapter, well, we'll be seeing the division algorithm and some more concepts like how to find the zeros of a polynomial, and finally we'll be seeing some algebraic expressions. So in the algebraic expressions there will be some common expressions like a plus b the whole square, a minus b the whole square, and some complex expressions as well. So follow along till the end of the video and watch the whole video to find out what are all the new algebraic expressions you can learn. So let us start with this chapter 2 polynomials, with continuing with the remainder theorem. So as of this video, the first concept would be the remainder theorem. It is actually a basic concept of the division algorithm. So I'll write division algorithm as DA. So it is division algorithm. So what is division algorithm? Well, let me explain it to you in simpler words. So when you try to divide two expressions, so suppose when I divide 15 with 2, you end up getting a quotient which is 7. So 7 2s are 14 and then a remainder 1. So any division consists of a dividend, divisor, quotient and a remainder. So let me express these as A, which is the dividend, B, which is the divisor, Q, which is quotient, and R, which is the remainder. These are the specific places where you can arrange these accordingly so that it is a complete division process. Now, what we will be extending this concept to is division with polynomials. So now this method you already know how to divide a number with a number. Now we can also divide some polynomials, some expressions like x square plus 2x plus 1 with a polynomial like x plus 1. Now I will tell some conditions which are necessary for this division to happen, but this is possible. And some of the same concepts which can be implied to this division as well are the position of this place A, which is the dividend. A is the same over here as well. Now the position of B, which is the divisor, is the same over here. So B is x plus 1, which is the divisor. Now you will be getting some quotient over here as well. So when you start dividing these two polynomials, you will get a quotient over here after division, which is the Q, and after some steps you will be getting some remainder as well. If the remainder is 0, well 0 is also a remainder, right? So you will be getting some remainder which is R. So these are the common notations I will be using for solving the division algorithm, so follow along with that. So let me take an example first. So the first equation given to us is P of x is equal to x plus 3x square minus 1. So this is our first equation, and our second equation G of x equals to 1 plus x. Now what are we supposed to do is that we are to divide P of x with G of x. So we have to divide this P of x with G of x and find the corresponding remainder and quotients respectively. So let us start dividing, and I'll explain the steps to you in a clearer way. So first, what you do when starting this division algorithm, I'll write it over here, DA, division algorithm, is that you first find the equation or the polynomial with a greater degree. Now greater degree means a higher degree. So what is a degree? Well, degree, as you know, is highest power of x in a polynomial. So what is the highest power of x in this polynomial P of x? Well, in this polynomial P of x, the x has the highest power as 2. And as of this, the power is 1. So as you can see, obviously this equation has a higher power, so hence the higher degree. Now what you are going to do is simply place this in the place of dividend, the A position. So you remember this step, right? A will be positioned over here. So P of x, place it over here since it has the higher degree. So you can rearrange the polynomial according to its degree. So what is the highest degree of this equation? 2 is the highest degree. So replace this to the first position. So 3x square. Now what is the second highest power? 1 is the second highest. So arrange it accordingly. Next comes the constant. Now similarly, you take this g of x, which is of lower degree when compared to this p of x, place it over here since this is the divisor. So place this according to the higher degree. So which has higher degree among these two? Well, x power 1, since x has the power 1, it has a higher degree, followed by the constant. So I'll be rewriting this. So x plus 1 divided by this whole term P of x, which is 3x square plus x plus x minus 1. So We did the first step, which is to rearrange this and place it in their corresponding positions. Now what are we going to do? Well, the first step was that, and the second step would be divide this 3x square with x. Now I'll generalize this step. What you are going to do is, whatever the dividend, take the first term and divide it with the first term of the divisor. So what is the first term of the divisor? It is x. What is the first term of the dividend? It is 3x square. So what you are going to do is 3x square divided by x. Now when you start dividing these two, you get 3x square, x and x square you get cancelled out, so 3x remains. So only 3x is remaining. Now what you do is simply put this 3x in the quotient place. Pretty simple, right? The step involves the division of this first term divided by this. Now whatever you are getting as your answer, put it in the quotients place. Now this is a temporary quotient as it is not fully complete. So now erase this step. Now you know what is the quotient of the first term of the quotient. Now what you are going to do is simply multiply each and every term with this quotient. So x times 3x will give us 3x square. 1 times 3x will give us 3x. Now there goes our third step. Remember, the first step was to rearrange this and place this accordingly. The second step was to divide the first term of the dividend with the divisor, and the remaining answer will go into the position of the quotient. And finally, the third step is to multiply each and every term of the divisor with the quotient and correspondingly write it below the dividend. So now as you can see, the powers are matching, x square and x square term, x and x term, and we don't have anything over here, so leave it blank. Now what you are going to do is subtract these two. Now you know in the normal division you are subtracting two terms, right? Suppose 15 divided by 2, the same example, you multiplied it with 7 as a quotient and 14. Now what you do is subtract, right? The similar step you are proceeding with this question. So simply subtract these two. Now the simple tweak over here is, you have to change each and every sign over here so that you can flip them. So suppose this 3x square has a plus sign in front and 3x also has a plus sign in front. So you have to flip their signs. So this plus will change into minus accordingly. So minus 3x square, and this 3x plus 3x will change to minus 3x. So minus 3x. Now remember this step. This is very important because when you are subtracting, you just have to flip the signs. So it was plus at first, now it is minus. Similarly over here as well. Now what you do is simply subtract these two expressions. Now 3x square minus 3x square is 0, right? Cancel them out, put 0 over here. Now x minus 3x square, it is minus 2x. And simply bring this down. So you are carrying it down so that you remain with minus 2x minus 1. So as you can see, the degree of this divisor is 1, the degree of this remainder is also 1. So which means you can proceed. So I will tell you again what you have to do. First, you have to multiply each and every term and then get with this expression and subtract it, flip the signs, get the final temporary remainder. Now bring over whatever is left out. Now what you are going to do is same steps. Just take, this is the new dividend. What you did over here, just follow those steps. Divide this minus 2x with the first term of the divisor. So what you are going to do over here is minus 2x divided by x. You will get minus 2. Now bring this minus 2 over here. So just write minus 2. So 3x minus 2 is our new quotient. Now 3x minus 2 is our quotient. What you did earlier was multiply each and every term of the divisor with the quotient, right? Do the same thing for this step as well. Multiply it with this term now. So multiply it with minus 2. First you multiply it with 3x, right? Now multiply it with minus 2. So x times minus 2 will give us minus 2x, and 1 times minus 2 will give us minus 2. So now what you do is simply put a negative sign over here because you are subtracting these two expressions. Now what you do is flip the flip the signs of these. So it is minus, so flip it to plus, minus, plus. So now evaluate this expression. Now forget this minus sign, just evaluate this expression. Minus 2x plus 2x, cancel it out, 0. Minus 1 plus 2 minus 1, plus 1. So your final remainder is 1, and you have solved the division where this is the quotient q, this is a, which is the dividend, this is the divisor b, and this is the remainder r. Your quotient is 3x minus 2 and your remainder is 1. So if you are asked with the question as find the quotient and remainder of these given expressions using division algorithm or long division method, this is what you have to do. Now let me take another example and clear the concept for you. So this is the next example where I will be showing you how to divide this and clear the concepts. So what you're going to do is divide this p of x with g of x, which is x minus 1. So the first step, as you know, is bring this to their corresponding places and represent them according to their corresponding degrees. So this has the higher degree, as you obviously know that this has the higher degree, which is 4. So bring this at the dividends place, which is over here. So write it accordingly with their terms, and this is the g of x which will be placed over here. And since you can see there is a term missing, which is x square, so that is the question over here. So you'll know how to solve that. So let us start with it. The first step which we saw was dividing the first term of this dividend with the divisor's first term. So 3x power 4 divided by x, which will give us 3x power 3, right? So now what you have to do is place this 3x power 3 in the quotients place. 3x power 3 over here. Now I'll erase this for the moment. And now the next step which you have to do is multiply each and every term with 3x power 3 or with the quotient. So x times 3x power 3 is 3x power 4, and minus 1 times 3x power 3 is minus 3x power 3. Now as you can observe, the starting term over here or this term over here will always be matching with this. Now that should happen because this term will always get cancelled out when you start the operation, which is the negative sign over here, which is the subtraction. So when you start subtracting this first expression, which is the dividend, with this expression, this first term should always cancel out in every step. So as you prolong, you will see that this first term will always get cancelled out. So let us start with the subtraction. Now if you announce the subtraction sign, what you have to do is flip the signs. So here it is plus 3x power 4, just simply flip it with minus, and here it is minus 3x power 3, flip it with the plus. Now what you are going to do is 3x power 4 minus 3x power 4 is 0, right? So cancel it out, 0, and minus 4x power 3 plus 3x power 3 is minus x power 3. Now bring this term over here, only one term at a time. So minus 3x is brought down. Now follow along with the steps with the dividend which we started with. So what you are going to do is simply minus x power 3 divided by the first term of the divisor, which is x. So minus x power 3 divided by x will give us minus x power 2, and just place this term over here. So 3x power 3 minus x power 2. This is our second term of the quotient. Now I'll erase this. Now what you are going to do is simply multiply this x minus 1 with minus x square. So x times minus x square will give me minus x power 3. Minus 1 times minus x square will give me plus x square. Now as you can see, similarly you got a matching term over here and it will always get cancelled out in this step. So now what you are going to do is minus sign and flip the signs. So what is the sign over here? Sign over here is negative, so flip it to positive, and here is positive, so flip it to negative. Now you can observe that minus x cube plus x cube will give us 0, but over here it is x term and an x square term. So what you are going to do is simply bring them down. So you don't have any term for the x term, so just simply bring it minus 3x, and you don't have any corresponding term for x square, so simply bring it, so minus x square. So you have these two terms at the remainder position, and you can't you don't have corresponding terms for the x to simplify and for x square to simplify. So you are just bringing them down in the place of the remainder. Now as of the next step, just bring this minus 1 over here. So as you can see, you have all the terms x, x square and minus 1, which is the descending power of degree of x. Now what you are going to do over here in this step is just rearrange this expression according to its degree. So minus x square will come in first, minus 3x and minus 1. So just rearrange this according to its decreasing order of degree. So I'll replace this term with this. So minus x square minus 3x minus 1. And now simply do the same as what you did over here and here. So take the first term over here, which is minus x square, divided with the first term of the divisor, which is x, and what you will be obtaining is minus x. So just add it over here. So minus x would be the next term of our quotient, and just multiply it. So minus x times minus x is minus x square, minus 1 times x minus x is plus x, and you don't have anything for minus 1, so simply leave it like that. And we should subtract these two expressions and flip the signs of these. So it is minus, so flip it to plus, and it is plus, so flip it to minus. And then minus x square plus x square cancel out 0. Minus 3x minus x, it will give us minus 4x. Simply bring the minus 1 down. You don't have any term over here. Now as you can see, it is of correct order, and you can do the same step as you did over here. So the first term is minus 4x, first term over here is x, dividing it will give me minus 4, and the final term of this quotient is minus 4, and similarly multiply all the terms of the divisor to that of the quotient. So x minus 4 is minus 4x, similarly minus 1 times minus 4 is plus 4. Now as you can see, just subtract it, flip the sign, so minus to plus and plus to minus, and minus 4x and plus 4x will cancel out to give 0, and minus 1 minus 4 is minus 5. So finally we have obtained the quotient, which is this huge term over here, and the remainder, which is 5. So this is the wrong division method, as you can see, where you can divide two given polynomials and obtain the quotient and remainder. If you like the content which I am providing, then please make sure that you subscribe to the channel and like to the video, and share this video as much as possible, because that will be very supportive to me. And please make sure that you watch this video completely, and see you guys in the next video with new content. So thank you guys for watching this video.